All right, we're back to low tech today. I am wearing my Angry Sai t-shirt, so if you're an Iowa State fan, I'm with you today. So, my neighbor decided to mow today in Iowa. It's been raining a ton, so we have to mow like 3 times a week. So, hopefully, the mower noise in the background isn't too bad. All right, let's look at complex variables. They're in the form a plus bi. Sometimes they don't have the integer start, I would say. So sometimes they're just in the form of like 3i or 4i, but they could be like 3 plus 4i, right? And we always put the integer part first and then the I part second. All right. So if you're looking at this and you're like, yeah, I don't, none of this kind of rings a bell. All right, let's go back to what we know, because good problem solving is trying something when you don't remember. All right. So one thing hopefully you remember is that the square root of -1 is I. And the thing that you have to pair with that so that you can do these is really you need to know if you square both sides that I squared is a -1. These two really are all you need to know. If you know those, you can figure other stuff out. Okay. So if I give you, say, I to the 8th, and you're like, I don't know. Well, you could say that that's I squared, I squared, I squared, and I squared, right? You know that. You know exponent rules. And then you could be like, oh, I could just replace all these and sub in a -1 over and over again and be like, oh, well, that's going to be a +1 then. Okay. So you could do that. All right. But that might get a bit much if you have huge numbers. If you're like, well, 401, I don't really want to do that. All right. But you could. All right. Just knowing I squared with an extra I, you could write out every number. Okay. That is possible. But let's look for a pattern. So I have I to start out with. So that's I. I squared, you just, we said we need to know it's -1. All right, I cubed would just be multiplying this by I, right? If I multiply both sides by an I get I cubed, so that'd be a -I. And then I to the 4th, I could do 2 ways. I could multiply by I again, which would be a -I squared, and a -1 is a +1. Or you could go back and do 2 of these, right? I squared times I squared would give you I to the 4th. Negative times negative is a positive. And then notice if you're like, well, I'm going to do I to the 5th. Well, that would just be this times I. So you're back up to here. And you're like, oh, I think I see a pattern. I to the 6th would be another I times this. I times I is I squared, which is a -1. Okay. Or if you're like, oh, I'm not sure I believe that. Well, I to the 6th is just 3 of these guys, right? I squared, I squared, I squared, that's a -1. And so you can see that this pattern is going to continue. So, and again, I don't memorize the pattern. I just remember that it goes by 4s. All right. So if that is the case, let's go back here. I to the 19th and this one. Okay. So I to the 19th, you would be like, okay, let's see, what's divisible? That would be I, and that would be what is 16 plus a 3. And you could write it like I to the 16th and I to the 3rd if you wanted to. But that 16 is going to land here. So then I to the 3rd, 1, 2, 3, this is going to end up being a negative with my I. Okay. And then what about I to the 401st? Well, again, I can write that as 400 plus 1. All right, so the 400 is going to land me there. One more is going to be just I. And so those first two aren't as bad as they look. All right, let's look at the next problems I gave you. Let's look at these two. You should know how to do these because this is just like algebra, right? I mean, if you know how to add 4x plus 1 plus 6x plus 2 and combine like terms, x's with x's, numbers with numbers, then these two, you're like, oh, that's the same thing, right? Numbers with numbers, what is that? 9. And i's with i's, that's plus 2i. You're just combining like terms. Here now, with subtraction, I like to add the opposite because the distributive property people mess up a lot in pre-calc. So we don't want to be those people. So we are going to add the opposite to distribute that so that we know that we took care of that. So I'm going to add, make this negative, and make that positive. So now I can just think money, debt, money, debt. I have $9, owe 10. That's a -1. I owe $4. I have 5. So that's just plus I. So those are very, you know how to do those, right? Not a biggie. All right, let's look at this one, multiplying. Well, again, that should remind you of something like this, where you either do FOIL, first, outside, inside, last. So you do the first, multiply, outside, inside, and last, and then you combine like terms, or you do the box, okay? I like the box, but I can, you can do either. All right, so you're multiplying. So you should have 4 parts. So I'm going to do the box, but you can do FOIL too if you remember that and you like it better. All right, so in the box, I get 6. I get a positive 8i. I get a negative 6i. And then here I get a negative 8i squared. Now, the only difference is with imaginary numbers is an imaginary number times another imaginary number has to create another imaginary number, which means it has to be in this form, okay? So I'm just going to double check, make sure I didn't make any dumb mistakes. I don't see any. And a negative times a negative is a positive. This is really a negative 1. And a negative 8 times a negative 1, this is really, I'm going to change it, it's a positive 8. And the I is gone, okay? Because I squared is a negative 1. A negative 8 times a negative 1 is a positive 8. So now notice, what do I end up getting here? 8 and 16 is what? 14. You write that on the front end. And then here I get what? A positive 2i, okay? So that's really kind of like doing algebra, except that, you can only end up with a binomial. Can't end up with a trinomial, a fournomial, impossible, okay? But very similar to that. All right, so then let's look at this one, and you might be like, yeah, Julie, I'm not sure what I need to do that. Well, that is very similar to radicals. So in a radical, if you have 2 over, say, 3 plus the square root of 5, we use the conjugate to rationalize the denominator. We don't really like square roots in our denominator. So in math, we're like, well, I'm just going to multiply by 1. Okay, multiplying by 1 is always legal. Well, what equals 1? Well, the conjugate is leave these exactly the same, but change the sign in the middle. Even if this is a negative 3, right? We can pretend that if it was a negative 3, I would leave this negative 3. So I have 3 square root of 5. I'm just going to change the sign in the middle, and I do that to top and bottom, okay, numerator and denominator, because this equals 1. I'm just multiplying by 1. Now, why do I choose to do that? Because I know if I have a number minus another one and a number plus, or sorry, a number plus is 1 and the same number minus that, on the distributive property, things are going to cancel that I want to cancel. Kind of going back to if I have this is the only time I get a binomial, because outside, inside cancel. I get a positive 5x, negative 5x, and then those cancel. So when I do the box, these guys are going to end up canceling when I do the box. Same idea here. I want these to be identical but opposites so that when I do the box or when I FOIL them out, those things cancel. All right. So on top, I am going to distribute that. So I get what? 6 minus 2 square root 5. Okay, and then on bottom, you can either do FOIL, the box, whatever. I'll do FOIL this time. First is 9. Outside is, let's see, what is it? Negative, the 3's are on the outside with the square root of 5. Inside would be the 3 on the outside, square root of 5, minus the square root of 25, because 5 times 5 is 25, and the square root of 25 is 5. See how those cancel. And what happens is you get a nice number there, which is a 4. And I can simplify these because 2 goes into everything here. So 6 divided by 4, divide by 2, 3 halves. These divide by 2, so I get what? Square root of 5 over 2. And that's my answer. So you're like, well, how does that help me with that? Well, I'm going to use what we call the conjugate. All right, so I am going to go here. I have 4 plus 3i, 2 minus 5i. Same idea. We don't like imaginary numbers in our denominator either. So we are going to just multiply by 1, which we do a lot in fractions, right? If you think of getting a common denominator, say you have 2/5, you might triple this and triple this to get 6/15. You're just multiplying by 1 to get maybe a common denominator. So we're going to use a conjugate, keep it identical as it is. If the 2 were negative, it'd stay negative. It's only the middle that changes. So I'm going to make that a plus this time. And we're just multiplying the top and the bottom, or the numerator and denominator, by that. Okay. In the denominator, again, I have to FOIL these out or do the box. Okay. So I'll just FOIL out. First is 4. Outside is a positive 10i. Inside is a negative 10i. and last is a negative 25I squared. These cancel, and notice I squared is a negative 1 again. So negative times negative is a positive 25. So that ends up being 29 in my denominator. All right, now we could FOIL out the top. I'll do the box this time just to show that. 4 plus 3I, 2, and then a positive 5I. All right, so I get 8. This is a what? Positive 6I. This is a positive, what is that, 20I. And this is a positive 15I squared. All right, I squared is a negative 1. So this is really a negative 15. So what do I get? 8 and a negative 15 is a negative 7. And then here I get plus 26I. And that is, you know, I simplified my division, okay? All right, so we use a conjugate. And again, if these would simplify, I would do it, but 29 and 7 have nothing in common, same with 26. So I'm just going to leave it as is. All right, the last one is, you might look at this and say, I don't see any I's. Well, yeah, not incognito here. Sometimes when you solve a quadratic, you bring this over, and remember, our goal is to try to factor, but I might try to factor for a little bit. I might try 6x and x and be like, if I put the 3 there, I get 18. If I do that, I know that's not looking good. I might try this for a while and be like, well, if I put the 3 here, I get 6, and that's not looking good. So I might spend a few minutes trying to factor, but if it's not going well, I'm going to jump to the quadratic formula. Okay, so the quadratic formula, the opposite of b, so that's going to be a positive 2, plus or minus b squared. A negative times a negative has to be a positive. So b squared minus 4ac. Okay, so there's my a, there's my c. And again, it has to always be equal to 0. All over 2 times a. 2 times a is 12. Okay, all right, I'm going to go to the next page here. Now, again, students mess this up all the time, so I highly, highly recommend just typing that in a calculator, right? So I would take my calculator. All right, and I just have Decimal Scientific up here. So I would just go, 4 minus what? 4 times 6, and then what? Times 3. All right, and I get a negative 68. Okay, so then I would just write 2 plus or minus the square root of a negative 68 all over 12. Okay. All right, so at this point, you're like, oh, there's the problem, right? So now you're like, oh, imaginary numbers when we're solving quadratic equations. And the answer is yes. And again, we expect 2 answers because quadratic is degree 2. So we're expecting to get 2 answers here. All right, so plus or minus. Okay, 68 seems like it would be divisible by 4. So we're going to try because 4 has a square root, and it is. Okay. So I am going to come over here and break 68 into the square root of 4, the square root of 17, and this was a negative, and a negative 1, okay? Because I need to get that negative out of there. All right, so the negative 1 is an I. Square root of 4, the 2 can come out, and notice the 17 is stuck. And that's all over 12. Okay, and then I can simplify each piece because the outside number is divisible by 2. So 2 goes in there once, and 2 goes in there 6, plus or minus 1 and 6 again. And again, our Newton or whatever homework system you're using, my math lab, whatever it may be, it might look like this, or since these have a common denominator, it's possible they just do something like that, where they have 1 plus or minus 1 squared, they put the numerator all together, divide by 6. That's a possibility. So really, it all kind of comes back to, if you know that beginning stuff, if you know that I is that, and I squared is a negative 1, most of this is very similar to other things you've learned in the past. So, all right, hopefully that's a quick review over imaginary numbers, complex variables. Hopefully that gives you a head start. If you need more help, let me know. Take care. Have a good day.